So welcome back, Level 2 NCEA Physicists, continuing on with mechanics, and this time looking at momentum and impulse. So remember work from Level 1 Physics. Well, work equals the force times the distance. So for this particular car, the work being done by the car is going to be the force, 5,000 newtons, multiplied by the distance it takes to do that force, which is 100 meters, which is 500,000 joules. And impulse, which is a new concept, is going to be equal to the force times the time it takes to travel at 100 meters. In this particular case, 8.9 seconds. So the impulse will be 5,000 times 8.9, or 44,500, and the units, because it's force times distance, are Newton seconds. So work is basically the change in energy, and impulse correspondingly is going to be the change in momentum. Okay, so the impulse is going to be the force times the change in time, which is going to equal the change in momentum, and that will of course be, because momentum equals mv, is mass times the change in velocity. If we expand that out, then it's going to be the mass times the final velocity minus the initial velocity. Okay, so the link between impulse and momentum is essentially the impulse acts to increase or decrease the object's momentum over a period of time. So change in momentum equals mass times the change in velocity. Okay, so there are many examples there we have of in sport and also in rocketry, which we see on the slide. So impulse is important when you're thinking about, say, cars and crumple zones, in terms of slowing down the time it takes for that force to allow that change in momentum. So how can we decrease the force acting on an object? Well, we see that in the next slide. Okay, so the impulse is the same in both cases, but in this particular case, the top case, the force is reduced, because the time it takes for that collision to occur is increased, whereas in the bottom example, which is what we don't want, is the massive amount of force and it takes a short amount of time, that change in momentum. Okay, so we want to increase the time it takes for that change in momentum to occur. So if the force is not constant, okay, then the impulse here will be basically the area under the graph of a force against time graph. It will be 40 Newton seconds. Okay, so remember when we thought about in level 1 how we did worked at the work done by a varying force. We just basically worked out the force over a displacement. Well, it's a similar analogy with force and time, and that gives us our impulse. So in this particular case, which impulse is larger? Well, you'll see from the area, both are actually the same, okay? Though the bottom one takes a lot more time in order to impart that force, which would be kind of analogous of crumple zones, say, in a vehicle. And the force actually does matter, because you see here in the example, the one on the left is basically that force is going to be applied over a short amount of time. That's going to break the egg. Okay, whereas if you apply the force over a longer amount of time, then that will not break the egg. So you see that a lot, say, if you're going to develop an experiment where you're dropping an egg off a building. Okay, you want to increase the amount of time it takes for the force when it impacts on the ground to be dissipated to the egg, so the egg survives. Okay, so finally, thinking about that, should a cannon have a longer or shorter barrel to produce a large final velocity? Well, the answer there would be, of course, it would need to have a longer barrel. The reason why is because that would increase the time it takes for that cannonball, the force of the cannonball, to be applied. Okay, so that's hopefully given you an oversight of how impulse works and how it's linked to momentum.